Hi, everybody. I am Tanya, and we will be speaking on the topic of secret management through Vault in a zero trust architecture. Okay, so before we move on, just a brief introduction about the speakers. So my co-speaker is Amit, and we both are working as software engineers in Mintra, and we are part of the platforms team who actually takes care of all the uh, tools and infra-related tasks of handling the logging systems, secret management, authentication, authorization, and all. So, without further ado, let's get started. So, today we will be majorly focusing on two aspects here, which is one is secret management, and the other being zero trust architecture. We'll walk you through how secret management in microservices should be actually on a high priority in any organization's list, and how management of secret in a zero trust architecture can be challenging, and how we in our organization have tried to solve these challenges. So let's start with first the problem statement. So uh, in a traditional network security models, earlier what used to happen was that people would establish a kind of boundary, or that we call as a perimeter, majorly in in case in the sense of a firewall, and then trust anything that made past that initial barrier. As in, there was a binary distinction of what is inside that firewall can be trusted, and whatever traffic that comes from outside cannot be trusted and is supposed to be not gone ahead with. Whereas now, when we talk about the cloud environment, we are moving away from the static IP based model. We are actually moving away from this distinction at the same time, because this the environment is so much dynamic that, and more and more it is becoming more and more ephemeral. We're launching new VMs as we go, as we are launching new workloads up and down as we even speak. So it is very hard to manage this static set of IPs, and that is why we are actually moving towards something known as a zero trust model. So what is a zero trust model here? So in a zero trust model, that binary distinction of whatever is inside my network is trustworthy, whereas whatever is outside my network is untrustworthy, that notion goes away. So what happens is that in zero trust environment, all the users are treated as untrusted, regardless of whether they're inside or outside the network. That means that every user, every workload has to be authenticated. Even the nodes or the devices on which they're running have to be authenticated and given an identity. And the after your device and your workload is given identity, based on that, we have to restrict the access to the resources uh, whenever we're granting any kind of access. So this is what the zero trust model is based upon. Now, when we talk about how we wish to manage secrets in a zero trust environment, I'm sure you guys would have already anticipated how the challenge in a very dynamic environment will come up, as in each application might be managing their own set of secrets, their own set of certificates. So it becomes really difficult if each application is taking care of their own secrets, and more areas to be prone for the attackers to actually get a hold of these secrets. So that is where the HashiCorp Vault comes into play. So Vault is a system that will centrally manage and enforce access to the secrets, and your application uh, is no longer required to manage their own secrets. We have a centralized place where we can um, manage all the secrets. So let's see in detail, like how, like what are the challenges that are coming for when we talk about secret management and how we plan to solve them. Okay, so whenever we talk about distribution of secrets in any network or in any environment, these are the major areas of concerns that any organization might have. Who has the access to the secrets? Who will manage the secrets? And how will I control, or how will any person or the security team control that what secrets can be accessed by what apps or what users? So uh, these points actually are the major areas of concerns whenever we want to design or leverage any secret manager that is present in the industry. So let's talk about more into what is HashiCorp Vault. So basically, HashiCorp Vault is a system that will help in managing your secrets centrally by securing them, storing them, and also providing them a tightly, coupled access to the tokens, the passwords, the secrets. It also extends capabilities of encryptions for protecting your secrets while they are sitting in your database. And all of this can actually be achieved using a UI or a CLI or even HTTP APIs. And the Vault, HashiCorp Vault, basically has multiple versions available in the market. The one that we are using in Mintra is actually the enterprise version. So just let's talk about few points of how and what all features of the enterprise version are we leveraging in the company. So as you all know, secret management, that is the core feature and is present in both the community version as well as the enterprise version. Now there is something known as identity based access, which actually enables, which helps us in enforcing the zero trust that we talked about sometime back. How it does is, and what actually happens is what we'll be talking about in our further slides. Uh, it also exposes the feature to actually encrypt your data and basically exposing encryption as a service, so that so there is a centralized place where you can just send me the data, and Vault will do the encryption for you and give you back the ciphertext. It also has improved scalability, where now we have something known as the performance standby nodes, so which are actually helpful for horizontal scaling of read requests. So your read requests and write requests are actually scattered between your leader node or the active node and your performance standby nodes. And there are multiple such features that are offered. However, based on your use case, you can leverage what is required by your organization. So let's move ahead, and yeah, let's talk about how we are enforcing zero trust using something known as Spire. I don't know how many of you are aware of what is SPIFFE Spire, but I'll just give a brief introduction. We will not go into much details. However, the brief knowledge is necessary to understand the further working of the systems. So let's start with something known as, so basically Spire is an open source project available. It is actually done by the CNCF company organization, and what it does is it is basically used to provide an identity to your nodes as well as your workloads or services which are running on your nodes. So now that identity is provided in terms of what we see here is SPIFFE ID. So if you see, it is a standard format for a service identifier. So the format goes something like SPIFFE followed by the trust domain. Now, what is a trust domain? Trust domain is something that you formulate within your organization. Say, for example, any request coming from the trust domain, any request coming out of this domain will not be considered as valid or authenticated. So this is what a SPIFFE ID looks like. Now moving on to SVID, which is SPIFFE Verifiable Identity Document. So when this SPIFFE ID is actually cryptographically signed by some asserting identity, we call it a SVID. Now that asserting authority, in our case, is known as the Spire server. So whenever a SPIFFE ID is actually signed by my Spire server, it converts into a SVID. Now, your SVID are of two types. One is your X509 certificates, or the other is JWT tokens. So, in our case, we are using JWT SVIDs for service to service communication. How that is happening, we'll see in the next slides. Uh, yeah. So just to reiterate as to what and how a workload can get its own identity. What happens is that the first step is that the node, your be it your Kubernetes pod, be it your VM, wherever your service is running, that node is given the identity. As we discussed that in zero trust model, we even need to authenticate the devices on which your services are running. So the first step is to get the identity of those nodes. The second is once I get the identity of my node, then we move on to getting the identity of my service. So yeah, if you see this diagram on the right side, what happens is that on each node there is something known as a Spire agent running, and where the service is also sitting. So this service will get the identity from its Spire agent, and based on some pre-validations, some checks, this agent will send that request to my Spire server. If everything goes fine, like if my agent has been verified, if my service has been verified, if all of those go fine, then this service gets something known as the JWT SVID that we talked about in the last slide. So even in our use case, every service has its identity in form of JWT tokens. And whenever my service A wants to connect with my service B, it will be presenting that token as an identity. And that service B will again validate if that token provided to me is authentic or not. So this is how we have given each identity to a service. Now see, now my service, my all the services have their own identities. They are capable of validating, uh, validating the tokens, validating each other's identity. Now, how we are doing secret management on top of this layer? So, what we have built is an in-house middleware service between our workloads and between Vault to facilitate their interaction. So, how this facilitation is happening? Basically, we have built an abstraction layer that will take care of all the necessary overhead which might be needed to you know leverage Vault as a secret management manager. And what are these tasks that are needed to be performed, we'll be talking about in the next slide. So using this middleware service, I will be having a single entity where with which I will be able to perform a uniform governance and policy enforcement across all the services that are running. And for zero trust, that we saw how we are actually giving an identity to all the workloads, but how we are enforcing them while accessing secrets, we'll see in the next slides. I'll hand over now to Amit, my co-speaker. He will be walking you through the design of this middleware service.
Thanks a lot, Tanya. So, as Tanya has already introduced you to the middleware service, I'll briefly explain the HLD diagram of how exactly it is working. So, as you can see, it has a lot of components, and any service can connect to the middleware service and finally fetch the credentials or maybe use other features we are providing. So let's start with the components. I'll start with the bottommost layer. First, we have this health manager. So it's like each of our component have its own health manager. Vault has its own health check APIs. Authenzy has its own health check APIs, and there is a overall health check API for the complete middleware. Then we have some alerting and logging engines. Logging is basically used for logging purposes, and alerting is alerting via over New Relic and whenever there is a failure or something. Then coming to the other components, we have environment handler. So basically, every company has multiple environments, dev, pre-prod, prod environment, and our vault setup is different in pre-prod as well as prod environment. So to prevent the access from pre-prod to prod, we have this environment handler which takes care of all these access and everything. Then we have the lease manager. So middleware service itself has to connect to the downstream vault to fetch the credential on behalf of other services. So it has to have some authorization and authentication system. So it is the job of this lease manager which fetches the token on middleware services behalf and refreshes it and uses it to fetch the to connect to the vault basically. Then we have authentication as well as authorization engine. This has already been explained by my co-speaker, the SPIFFE Spire, which we have been using. So we'll move to Vault Broker. So Vault Broker, basically, this is the layer which is responsible for connecting to HashiCorp Vault. So this is the layer which connects to Vault via its own HTTPS APIs and perform all the features. Then moving ahead, we have this control plane. Control plane is basically the brain of our middleware service. It redirects all the requests to certain components on the basis of their payload as well as headers. Then moving forward, we have this REST API layer. So this is the exposed layer which is exposed to all the services inside Mintra. Basically, it has all the endpoints through which you can connect to the middleware service and perform the functionalities we are providing through the middleware service. So this is the overall high level design of what middleware service has, its components and how it is working. So I'll move forward to briefly explain what all the features which our middleware service is providing. So these are basically extended from Vault itself. So the first feature which we are providing is sensitive data encryption and decryption. So we are providing sensitive data encryption and decryption as a service. This means that service can send, all the services can send the plain text and we'll return them the ciphertext in case of encryption. So basically to ensure that no service can decrypt any other service's ciphertext, we are using service name basically and the SVID token being passed in the header in the encryption path itself. So Vault basically encrypts and decrypts and does all the features, all the jobs basically to a certain path. So we are storing the service name as well as the SVID token there itself so that no one else would be able to decrypt other services ciphertext. Moving forward, we have sensitive data read and write. So this is also path based. that the services need to provide their service name in the secret path where they are storing their sensitive data, and we are saving the service name there itself, so that no other service has authority over some other services data. Next, we have dynamic DB credentials. So basically, let's say a service wants to have credentials, short-lived credentials over a certain period of time. So HashiCorp Vault has this feature as well, and we have extended this to provide DB credentials for a certain TTL. And then we have key rotation feature as well. Basically, someone wants to rotate the keys, and that is also we are providing. So moving forward, I'll explain you the sequence diagram for sensitive data read API from Vault, which is using our middleware service, which is inbuilt. So we have certain components, upstream service, which will be gonna connecting to our middleware service. Then we have authn to authenticate and authorize the request. And then we have our downstream vault, basically, which has all the credentials and the service is trying to read it. So the endpoint exposed is slash sensitive data slash kv slash read. So any upstream service basically can connect to our middle stream using this API. This API consists of two parts. One is the header and one is the payload. So header basically consists of your SPIFFE SVID token. So this is used to authenticate the request. If this SVID token, let's say, is invalid or expired, then our system will return 403 unauthorized access. And then we have our payload. Payload consists of the secret path basically from where you need to read the data. This secret path also contains the service name. So how we are authorizing is that the service name in the secret path must be exactly same to the service name we are getting from the SVID token to SPIFFE ID. So only if they match, then it is authorized. If there is a mismatch, we again throw a 403 unauthorized error. So once this all authentication and authorization has been done, verification of SVID and everything, our middleware service calls the downstream vault through its HTTPS APIs and fetches the secrets on behalf of all services for them. Once the secrets are successfully fetched, it gives the 200 response back to the upstream service with the data what they were trying to read. So this is how the flow of sensitive read is within our middleware service. So basically all other services are similar to this, and we have exposed certain endpoints, and the flow is quite similar to this. So moving forward, so what we have explained now, how services are authenticating and authorizing themselves to the middleware service. The thing left is how middleware service authorize and authenticate itself to the vault to fetch the secrets or provide the features on behalf of other services. So for authentication of middleware service, Vault has its own identity-based access. So Vault has certain number of auth methods like K8's Kubernetes auth methods, Azure auth method, OIDC, and a lot other auth methods. Inside Mintra, we basically have a hybrid architecture right now. The services are running on both Kubernetes environment as well as Azure VMs. So we decided to go with a hybrid environment setup for this middleware service as well. So I'll briefly explain the Azure auth method. K8's method is quite similar to it, just that instead of Azure JWT token, we have a service account JWT token, which is used to authenticate the middleware itself. So how Azure auth method works is that let's say the middleware service is hosted on an Azure VM. So it has to first log in itself to Vault and fetch a client token, which it can use basically to serve the HTTPS requests or serve the features which the upstream services are asking for. So it will first fetch the JWT token from Azure open endpoints. Once the JWT token is fetched, we hit a login API. Vault has its own login API, HTTPS login API, along with the metadata and JWT token. We pass it. Then Vault verifies if the token passed is correct or not. Once verified, Vault returns a client token basically to our middleware service, and that client token can be passed in the further Vault requests to complete the feature requests. So this is how the middleware service is itself authenticating to the vault service. So why this is beneficial? Now we have taken all the load from the services to manage their own to not to authenticate to vault, and it is job of this middleware service just to complete the request on their behalf. So now moving forward, Vault, a middleware service itself has to authorize itself as well. That whether it can read certain parts, where it can decrypt or encrypt certain parts or not. So for this, basically, Vault uses policies to govern the behavior of clients and instrument RBACs, role-based access control. So that is how Vault provides this. So we are using Vault policies, defining a list of paths for our middleware service through which basically it can access certain paths, perform read, write, or delete operations on them, and no service except middleware service can do these things. So that is why this is completely the job of middleware service, and it is a bridge between upstream services and downstream Vault. So this was how middleware service itself authenticates as well as authorizes to the to the downstream vault. So coming to the highlights of the middleware service, what exactly and how this is beneficial. So first thing is ease of integration. So we have around 500 services plus inside Mintra. No, it can't be go like this that each service connects to Vault on their own and tries to perform the credentials. There definitely has to be some middleware or central service which can do this on their behalf. And since we have exposed a lot of endpoints for this purpose, this integration is quite easy for all the services. Just hit the APIs, send the SVID token, and get 200 response. So then we have automated through our lease manager. We have automated Vault token and refresh and basically refreshing is also automated, and now it has offloaded all the jobs from application to the middleware layer. And next is zero trust enforcement. As already explained, using SPIFFE Spire, we are providing zero trust enforcement. Then coming to the availability of this service, we basically have a hybrid model, which it is running on both Kubernetes as well as VM environment, and we are trying to provide the best availability possible. Then coming to the reliability part, we have a dedicated health check module to constantly monitor the health check of all the underlying systems. We have New Relic and Zenduty alerting, and we have been using all these alerts in case of any failure scenarios. So this is how we are providing the reliability for our middleware service. I think this is all what we had. And if we have any doubts, we can definitely go to the Q&A section.